1, start streaming. Now let's see if it's sending a feed to the...
Says you're live.
Yep, we're live.
All right. Just gonna make sure I have the right thing here. There's the 6-3, and here's the 8-1. Oh boy. It would appear that we are up. I just want to make sure it's going on my end.
I've got your stream rolling good on YouTube.
All right. It's very convenient because the way I'm sitting, my mic where I have positioned blocks out my own face, so I can't actually see my own face. That's fantastic. Welcome back to another United Weather Network podcast focusing on the current situation of the strong earthquakes and significant earthquakes occurring over the Western Pacific. My name is Morgan J. Fold. Kyle, Josh, Greg, and special guest Amy Metz here joining us this evening to talk about what's going on with the seismic activity in the Southwest Pacific and what it could mean going forward for areas potentially in Indonesia and even Greece. As we're seeing on our screen here, there's a little swarm of earthquakes occurring in and around there as well. So welcome one, welcome all, welcome Amy. Appreciate you having us. Appreciate you joining us, rather.
Right.
So we're not going to hesitate because there's a lot to cover with this. Most of us have seen, well, some of you guys saw it when it was happening. I saw it about 6 hours later. An 8.1 occurred north and east of New Zealand, Kermadec Islands. Relatively shallow, relatively strong at the surface. Now, this did trigger several different tsunami threats for these areas, and there were multiple 7s and the 8 in the same day yesterday. So the 7.3, the 7.4, and the 8.1. And in this case, a big tsunami was not generated here, but the threat was definitely present. But dodged a bullet with that one. So at this point, I'm really just going to hand it to Amy to discuss really what happened in the situation that could be unfolding in front of us.
Hello. So the reason, my name's Amy Metz, by the way. I'm a meteorologist studying space weather, and there have definitely been correlations between our seismic activity and solar cycles. So right now, we are trending toward a point, per other studies that have been done, that we might see more and more seismic activity. So Papua New Guinea had quite a few earthquakes earlier, just about a month ago. There was a small tsunami generated northeast of Australia that did affect the Australian coast with a small tsunami that I had forecast for. Knowing how many forecasts we have that flop for tsunamis here in Hawaii, I have been taking extra focus on tsunamis and whether they will or will not develop. So I've noticed if it's at a depth of 7 kilometers with a magnitude over 7.0, then there's a chance for tsunami activity. Now with that 8.1, that was definitely something that could have generated a tsunami, and there was a small little surge of wave around the high tide time also, but it was very small. And the reason I forecast that if anything happened to be tiny for New Zealand is because there happened to be a big swell moving into the same direction that the earthquake was coming from. So they were able to collide, and instead of having a bigger wall of water, it would lessen that blow. Plus Neuron, a major cyclone, is over there too, helping blow things away, and that was generating part of that swell. So when it came to Fukushima, that was my very first time working on a green screen 10 years ago, and that actually generated a tsunami that went all the way from Japan across the entire Pacific Ocean and caused deaths and insane damages over in Orange County, California, where I am from. So knowing that there were nuclear reactors, I believe that even though it was a depth of 30 kilometers, that had something to do with the strength and severity of that tsunami, that a 9.1 that deep would not always necessarily cause such a huge wave. But with it being, associated with the nuclear reactors, I think there was an additional force because a lot of that blew out even more energy with all the nuclear pollution that was going out with it. An insane amount of energy. So now with this 8.1, 30 kilometers deep, it's pretty unlikely from what I've seen and what I've studied that would generate a big wave. So I was really grateful I could say no, and then seeing that swell was like a double no. So that's what I have on those. If you have other questions, go ahead, but I'm noticing this ring of fire is going off and off and off, and we're in that solar cycle where it might keep on going off more and more.
Yeah, and the interesting correlation to all of this actually has to do as well. Which actually, the somewhat spooky thing about this is a week from yesterday, March 11th will mark the 10-year anniversary of the Japan megaquake, which she was just mentioning, the 9.1 off the coast of Japan, which triggered the Fukushima disaster, as well as bringing that wave all the way across the ocean into California coastline in that case.
And solar cycles are 11 to 14 years, by the way. So that 10-year mark, I mean, that does have a big impact on us realizing now, okay, this could be a trend.
Yeah.
I was going to say, could you explain the difference between the sliding earthquake and a thrust earthquake?
I'm having a little trouble hearing you. You said declining what?
The thrusting earthquake, where the plates thrust upwards, and
yeah, like a thrusting earthquake versus one where plates are just sliding.
Subduction and slide.
Yeah, now I have a lot I could learn on that. I've taken a couple of science classes where, and many of us have just in basic high school. But yeah, there's the chance that these tectonic plates are just rubbing, and then a little bit of wiggle happens that jolts the earth. That probably wouldn't, make a huge tsunami unless there was an extra swell or something to go with it. But then when there's the types that will hit each other and converge and rise upward, that pushing together, causing upward motion underneath the water surface, that will definitely force water to go up and outward. So do any of you know if there are sources to find out what kind of earthquake that was, or could be? From my understanding, I think it takes a while to figure that out.
Yeah,
and I think
it does take a while.
Yeah, and I think considering it happened yesterday, I don't think they'd have information on that, but I'll run a search.
I believe it takes like a survey. If I'm not mistaken, I think they do some kind of survey.
That would be my best guess.
Okay.
Which a lot of times I can tell, depending on what kind of, if it's a known fault line and everything like that, they kind of know what type of.
Probably satellite imagery as well. Sometimes you can see actual visible splits. You know what I mean? I lived out in Arizona and I saw where a past earthquake had happened, and it literally split the rock like visibly, like to where you could see where the earth slid, because it was this white shape that was perfectly round before, and then there was like red rock around it, and you could obviously see it was like split like this. The one white side was here and here. So that's pretty crazy. That's how much of force that had.
You could imagine that kind of pulling apart could suck water down, and then that would have a reverb that would force it out with a tsunami. So something I wanted to talk about too, I just found out about, and I shared the link here with Morgan, was the Schuman Resonance, something I'm just barely beginning to study and look into, but that peaked and it rose pretty high just before those earthquakes. It was higher right before the larger earthquakes, and then a little bit smaller rise before the other earthquakes that were more like 6.0. So there could be a link there as well for a quick, maybe like an few hour lead time on warning before an earthquake could hit.
Yeah, and I'll bring this up here. So really,
I was gonna say one thing to Josh. The other week we brought up there was a 1,782 foot tsunami before up in Alaska, and that's because it happened in a river. That's pretty wild.
That was the one that ran up that river.
Yeah, I can see Amy's face. That's kind of like.
No. No,
Yeah.
yeah, there's no running from that. I mean, unless you have
Uh-uh.
tall mountains and a lot of time.
The initial wave hit about like 1,700 feet in the air, and then the rest of the sound got about like 300 to 100-foot waves as it exited. I think it was in the 1950s, if I'm not mistaken.
Yikes.
Yeah, pretty
God,
wild.
the kind of impact that would have today
Uh-huh.
it be somewhere of relevance, somewhere of populace. There's no running
Mm.
from that. It's
No.
just even if you enact something like contraflow on highways and stuff like that to try and get people out, there's only so many that can get out.
Yep.
So
Yep. It would be a
and
chaotic nightmare.
mhm. So
The early 1900s, wasn't there California, Northern Cal, or Oregon, Washington, wasn't there a big tsunami that hit there and wiped out a town completely?
yeah,
Like
it did
1906 or something like that.
something along that line. Josh, you're very faint.
Something.
Um, so yeah, and what Amy mentioned with this particular earthquake is it had a depth of 26.5 kilometers, which is relatively shallow, but not really
Mhm.
shallow enough if we're trying to get a tsunami, which is great news for these areas. We've really lucked out in terms of tsunami waves with the past significant earthquakes of 7+, because I know we had
Mhm.
one in Alaska over the summer. Then we're getting these down here. We had one off Japan, all of which were
Mhm.
relatively shallow, and we're pretty much lucking out at this point with any kind of significant tsunami threat.
It's only a matter of time, though.
Yeah, and I'll go into what I'm talking about in terms of trends for quakes, and we'll also go over what's happening in Greece, which I mentioned at the beginning. But let's just take a look at the map here of recent earthquakes. So I have this shifted to look at the largest first. So you can notice the 8.1, the 7.4, the 7.3, and the 6.3 all happening within the same day at completely different times, all of which were at least 2 hours apart from each other. So taking that into account, as well as the fact that there were stronger earthquakes before this that happened at different times, that's definitely something to keep in mind and something that you're going to have to monitor. And as well, noticing the many aftershocks of 5+, which are also pretty significant to these areas in terms of releasing energy. And with what, in terms of the energy, we should begin to see a kind of change in where energy is located. So now that we've really, actually, what I will do at this point is I will switch over to my other earthquake application here. So we've gotten the big earthquake that we had been mentioning on and off here and there for a long time, and it's occurred north and east, my apologies, of New Zealand, Kermadec Islands. Now that we've gotten this, in correlation with the quake activity we've seen around Indonesia, up east of Asia, and as well as what we have going on in Greece, we're already starting to see signs that the energy is beginning to shift towards the north and the west, away from these islands, towards Indonesia, and potentially south of Japan. Now, with this being said, the earthquake situation in Greece is something that I haven't seen personally. So you see the 6.3 that is marked here, that's magnitude on the Richter scale, shook these areas in Greece, and it was directly over land as well, directly had populace in the way. It was a very shallow one as well, so there was a lot of surface impact. There was a lot of effects that occurred on land, and even involved some kind of volcanic incident. So what's interesting is the lack of signs of this actually occurring in the first place. So you guys see the trailing fours, 4.2, 4.2, 4.2, 4.2, but really nothing that signified any kind of direct impact heading towards Greece. So it brings up the question of, did some kind of energy transfer under the core? Did some kind of energy transfer below the surface where there wasn't really any effect noticed? That's the main question, and if that's the case, then us as forecasters, it's going to make it very difficult for us to try and forecast any kind of trend in terms of earthquake direction in this case.
Well, See, last night we were talking about how a lot of them were popping up. Would be one in New Zealand, and then it would pick up an antipodal earthquake in Greece, and almost immediately after, it would just be
Mm.
back to back to back. And
Mm.
I was looking into it because I wasn't sure. I've never heard of an antipodal earthquake before, and apparently that basically means it's coming from somewhere on the 180-degree opposite of where it's actually happening.
Mm.
So that energy had to come from the opposite side of the planet, which is funny because all the situations in New Zealand are almost exactly parallel to Greece when you look at where they're spotted on the map.
latitude wise, right?
The
So
the exact I think the exact opposite of New Zealand would be Spain, which is right next to Greece.
mhm.
That's pretty crazy how it drills right through to the other side of the world.
So
I
nailing the eight.
wanted to add, when you're ready, I'll add something to that.
So nailing the 8.1 here, you see a location of it 29.735 south, 177.282 west. If we go over towards Greece here, 39.734 north, 22.176 east. Right there, almost nailing it perfectly in terms
incredible.
of the paralleling locations on the planet. And Amy, you were saying you're going to add some, so I'll let you have a voice.
Yeah, so I just learned the other day in class with sunspots and solar cycles that most of the time the sunspots will be about the equator at certain times of the solar cycle. So right now we have one that they're called conjugates. So one is, like you're saying, at a similar location and latitude about that equator, the magnetic equator in the case of the sun. And so this is reminding me now, the other earthquakes that happened, including this one, they happened about 5 days after a large coronal mass ejection had left the sun, inputting a bunch of energy into our magnetosphere. So these things could very well be connected, and this could be a trend that we should be watching.
Yeah, for energy ejections on occasion sometimes leads to
wild.
stronger quakes. Yeah, great thing to note. So I had mentioned the other week that the potential for a strong earthquake up and down the west coast of the North American west coast was getting higher and higher, and now I can actually say with some sort of confidence that now that we've had the big one that's really starting to move the energy, that's becoming more and more likely. And what we should start to see, although this isn't what we want to see, we should start to see smaller 3-4 earthquakes up and down the west coast. Now, if we don't start to see that, that's going to be a bit of a concern because there won't be as much of a pressure release. We really want to start seeing that pressure release because the more that actually does start to let up and the more that does release a tad, the less chances there are present of a strong earthquake occurring. And the more pressure that builds up, the stronger the impact will be at the end, and that's not what the people of the West Coast need at this time. But just taking a look at it here, you guys can see stronger earthquakes occurring around New Zealand. What we're going to start to see in correlation with this is we're starting to see an energy transfer up to the west. Now we should start to see over the next week or so earthquakes start to occur over Indonesia, portions of the islands, south of Japan. Areas like that, we should start to see a pickup in activity there as it's been relatively quiet. As that pushes off towards the north and east, we could start to see some more activity around the Alaskan coastlines going down British Columbia towards the west coast. And in fact, the other day we actually did have 5.4, 5.3, and there was also 5.2, if I remember correctly, noted in and around those areas. So there is definitely energy present there to produce these kinds of earthquakes off the coast of Alaska that could have some sort of significance to life and property if they can get a little bit further inland. The main concern here in terms of the populace is along the U.S. West Coast, because there's a lot of population up and down California, up through Oregon, Washington. That's really the main concern here. I'm trying to find. So this, this is another thing that I wanted to note, and this is something that is of relative concern to me. And if any of you guys, I see all y'all muted down below me, if you guys want to get a word in, just say something. But what we notice here is the lack of activity in these areas. So this is the earthquakes that have been occurring near some major volcanoes. So Rainier's had a fair bit of activity in terms of tremors. That's good. Hood has had a spurt in one single day, had a bunch of them. It's a pressure release. That's what we're looking for. St. Helens is here and there, and the concern here is if these earthquakes don't really let up, or any kind of pressure that's building up in these volcanic regions, a stronger earthquake in these areas could also bring a volcanic threat. And areas like this haven't seen something like that in years and years and years. And if pressure builds up along the fault and in the volcanic regions, that's just a setup for trouble at that point. So what we're going to be looking for, and even Crater Lakes had one over the last 30 days, what we're really looking for is an uptick, hopefully, in tremors. If we start to see an uptick in tremors, that means pressure is being released. The energy that's present is going to shift down to those areas. Hopefully the pressure will begin to release up and around there, because that would mean that the chances of a higher or stronger earthquake in those areas are getting less and less by the day that there are more tremors.
It's been like 42 years since Mount St. Helens erupted.
I was gonna say it erupted in 1980, and that was the last time they had a volcanic eruption in the state of Washington.
Mm-hmm.
So
they're pretty much due for one.
Yeah, 40 years.
It's a long time.
Amy, do you have a note on that? Because it looks like you aren't actually.
I just hate hearing they're due for one. I mean, as far as, I can put in with this cycle variability, like I mentioned, it would be on track for that again. So when it comes to the actual volcanoes, I've not studied as much, although I'm near a volcano that erupts often. Any of those kind of ground tremors, though, can definitely have an impact on those releasing. So if we do see a bigger earthquake there, yeah, I think that would be the number one thing to be worried for.
Mm-hmm.
Have another Mount St. Helen issue.
Yeah, which could
that was disastrous too.
That was a big issue, and with populace building up in around there, that would be even bigger of a problem. I want to bring up something briefly that I read the other hour actually about these areas in Oregon, the Cascadia subduction zone. So I'm just going to read this out here. Pacific Ring of Fire, a 25,000-mile-long region that outlines the northern and southern hemispheres of the Pacific Ocean and also the Pacific Plate. 80% of the world's earthquakes occur along tectonic plate boundaries, where tectonic plates come together and build up stress as they attempt to get by, under, or over one another. When the strain is too much on the plates, the plates suddenly slip past each other, releasing the energy in the form of an earthquake. This sudden release of energy creates seismic waves that travel through the Earth's crust and make the ground shake. Earthquakes don't occur instantaneously. Instead, faults underground rupture like a zipper opening over tens of seconds. Just off the Oregon coast lies the Cascadia subduction zone, a major tectonic plate boundary. When these locked plates finally release, the result will be a powerful earthquake capable of causing extensive damage to homes, buildings, and infrastructure along the state, with additional destruction from a tsunami that will inundate our coastal communities. Tectonics in Oregon also produce deep earthquakes, like the 2001 Nisqually, Washington earthquake, which shook our region for tens of seconds, as well as shallow crustal earthquakes, such as the 1993 Spring Break quake, which caused concentrated local damage in and around Scotts Mills, Oregon. Even sources like this are saying that a strong earthquake will have significant impacts, and what we can do is we can tie that in to the lack of activity in and around those areas of Oregon. Pressure seems to be building up, and this is around the Cascadia subduction zone just off the coast here. Pressure is building up. We had a 4.0 there the other day. We had a 3.0, 3.1. So some pressure is being released, but not a lot. We're going to have to monitor over the next several weeks to several months even, where this energy shifts, if pressure is being released, and the potential impacts that could come. Now, for areas like this, up and along the west coast, up through Alaska, and along British Columbia, I mentioned this in a video that I did the other night. I did it last No, I did it this morning. Wow. This morning, video that I did, if an earthquake actually does occur, and again, like I said, with the quakes occurring in Greece, with nothing showing up and around here in terms of some sort of trend indicating towards that, you really rather be safe than sorry in this case. So, if you live in these areas, especially with the shift in energy that we're starting to see, you want to make sure that at all times for the next few weeks, few months, you want to have non-perishable food, water, clothing, medications, phone chargers, toiletries, and a battery-powered radio on hand with you in case of emergency and in case an earthquake strikes. You never want to take a risk with this, especially considering the amount of uncertainty that has been present with the timing of all of this. We really can't forecast this too particularly well at the moment. But what we do know now is that the strong earthquake has occurred. We're going to have to monitor trends for the next few weeks and monitor locations of stronger quakes, stronger swarms of quakes, larger swarms of quakes, all that stuff in terms of that, and of course pressure release up and along Mounts Rainier, Crater Lake, and Mount St. Helens. Amy, Greg, Kyle, any comments? Josh?
Well, I was just gonna say, you always need to keep at least a 72-hour supply of non-perishable goods. You never know what kind of situation you'll be in.
Yeah, multi-day in case an emergency does occur.
And always keep at least a quarter tank of gas in your car was a good note made to me, told to me to, so you can always get out of town if you need to last minute.
Mm-hmm. Yeah, and despite what we brought up earlier about a significant earthquake occurring, if evacuations have to take place, there's only so much you can evacuate. There's only so many that can evacuate. Make sure that you are in a position to be one of those people that can evacuate. Make sure you have gas, make sure you have food, water, etc. What I just mentioned on hand, easy, ready to go so you can get out when you need to get out. With this being said, we're going to switch over to a little bit of severe weather forecasting for the next couple of weeks.
I was going to say one thing, Morgan.
Yeah.
I was going to say, if you can't get out and evacuate, the best place to be is outside, away from power lines and buildings. And if you can't get outside, then you have to get under something very sturdy in your house.
Yeah.
But the best place is to just kind of run out the door and get away from any kind of buildings or power lines. And then keep in mind, I mean, obviously the ground could break in sections as well, but I'd rather be outside and take my chances than being in a building.
Yeah, definitely.
Mm-hmm. And in an event like that where earthquakes are very sudden, and hopefully with newer technology and that kind of resonances that Amy mentioned that we were talking about earlier, hopefully we can begin to detect earthquakes a little bit in advance before they actually occur at the surface. That also depends on the nature of the earthquake, if it's shallow as well. So if it's less shallow, you're going to have less of a time you're going to have less time to prepare for that. But if you do happen to have time ahead, you're going to want to make sure that you're outside, stuff like that, in an open area away from any kind of structure. Apologize about that. But, like I said, with further models and detection about when earthquakes could occur, there is the hope that we can begin to inform the public earlier rather than later when these kinds of events occur in the event of an emergency situation. With that being said, if none of you guys have anything else to say,
I totally agree with that.
Yeah, I'm going to switch over to a tad bit of severe forecasting. This is going to be long term because there isn't anything short term to really take a look at. So we had the marginal risk of severe thunderstorms today for winds and hail over the Houston-Galveston area. That did nothing to my to my understanding. So we're going to look ahead as to what to expect over the next few weeks. So that MCS that we mentioned which could have soaked the Carolinas that Josh and I were talking about last week, that has ceased to exist on model runs, so we don't need to worry about that. But going forward, we're going to start to see a little bit more of a settled pattern going into the beginning of next week. High pressures are going to take place over most of the country. Very little amount of precip expected except for the higher elevations of the Pacific Northwest and potentially even coastal areas. Maybe some slight snow showers over the UP, but really nothing that's going to be any kind of significant accumulation. Timing moves along. That high pressure really likes to sit over the East Coast at that time, so that'll shift off the coast after a few days to maybe even midweek. And what we're going to see is a low pressure forming, a trough digging south. And what we're going to see off a cold front here is we're going to expect some thunderstorm development to occur along this front, along this boundary going into the Midwest. Now, models have been indicative of this and also consistent of this over the past week or two. And
I believe it'll dig into Oklahoma a little more than it's showing right now, too.
Mm-hmm.
I've been looking at this.
So you can actually, on that note, notice the tangent low that occurs if the trough.
Next few screens will show that they're picking it up, I think.
Good. I can't see the day. It's too small for me, but okay, that's good to hear then. And then the horror for the southeast, because it is more so their tornado season.
Indeed. Mm-hmm. So, and in terms of what Amy
there's that next system there.
Yeah, there's the next system bringing rain storms to that area.
Another one will develop around New Mexico.
Yeah, and there's something that we're going to need to talk about right there, and what that actually has in terms of impacts futuristically. We're going to have to watch this storm that also has been noted across several ones for the potential
there you go.
severe weather.
That's the stuff right there.
Strong MCS.
I'm waiting for it.
Yeah, strong MCS that would occur over the southwestern Ohio Valley. Now, this would be a big severe threat, happen this verified, and happen this have decent thermos. Because at this time of the run, I'm going to scroll back a little bit to this particular time frame, and then I'm going to freeze it. At this time of the particular run, what we have in terms of shear present, because shear allows thunderstorms to develop and sustain, allows them to form, we have a really nice amount of shear. In terms of the mid-levels, over the Arklatex, the very eastern portion of the Arklatex, mainly Arkansas, Louisiana, and Texas, as that shifts up towards the north and east. In terms of 850 millibar winds, which is what's closer to the surface, you can, again, see a lot of shear present in this area. That would allow thunderstorms to develop and allow them to sustain relatively well going into these areas. And the sustainability has been a prime issue with storms over the last year, because storms seem to form and die, which actually those exact storms that seem to form and die in terms of a tornadic storm have been the most damaging. So
Josh, you might want to get your supplies ready, bud.
Yeah.
I was about to say, it looks like Josh and Johnny Parker down there are going to be getting some weather first before anyone.
Yeah.
I've got trauma kits and all kind of stuff ready. So.
Nice.
But yeah, that right there, just to look at that, that could be that would set up for a supercell.
Oh yeah.
I'm gonna have that line.
And you can even see shear close to the surface in the form of 50 knots. So
that's what I was thinking. You can't see your values. I've been forecasting from 35 to 50 once it hits this area. I usually don't look at models, honestly.
And that's what all.
You want to run a cape on that, Morgan?
So I will, but it's
right now.
It's still far out, but yeah.
Yeah, and it's the goofy forecasting system. So
I
not a lot. Yeah. So it doesn't really pick up thermos that well, but you can vaguely see the energy that attempts to lift north in the form of the Cape offshore. Now, it does actually say a few traces of it in the form of 100. There will likely be more than that if the event actually started to occur. But in that case, Josh?
I was going to say, I mean, next week, that weekend, highs are supposed to be pushing 80 degrees here. So,
most likely a outbreak or some sort of severe weather. Oh yeah, look at that line right there.
let's note this is the cold front. This is at 3Z. This would be 10 Eastern, 9 Central time. This is by nightfall. This is when nightfall has occurred. Actually, sorry, this would be, if I recall, wouldn't this be 11 Eastern, 10 Central? Because daylight savings.
3Z, wouldn't that be? I mean, isn't that 3 a.m.?
Daylight saving time's coming up.
3Z is universal.
Spring forward. I'm sorry, but yeah, you're right.
Yeah.
Okay, yeah, no.
Yeah, 3Z is universal, and I have to readjust my mind again
Yeah, we gotta
to daylight
calibrate that.
savings, which is rather unfortunate because I had a really difficult time doing it in whatever month I had to do it in, and now I have to do it again. But you can see the temperatures, even in the middle of the night by nightfall, rising into the 70s for portions of Mississippi. This is specifically Jacksonville over this marker here. You can see high 60s. And even
That's
70 as this
Jackson,
marker.
Mississippi, yeah.
Yeah, and even 70 as this marker is saying.
Yeah, with my forecast, and I look a lot at preconditioning. So right now there's not a lot of clouds or moisture there, meaning they're able to warm up. And then on top of that, before this cold front gets anywhere near the central U.S., there's going to be more of that warm, moist air funneling in from like over the Mexican plateaus and from the West Coast by Baja California.
Indeed.
Yeah,
So,
definitely.
so the newer forecast trends have been focusing on energy and pressure systems starting to develop over and around the South Rockies, and then eventually shifting east. Now, this is the same pattern that we had last year that ended up producing those outbreaks of tornadoes across portions of Dixie Alley, particularly in these areas. So, remember Bassfield Sosa, the 4 that occurred on Easter.
And
This
Soso
is-
as well.
Yeah. So this is the very similar setup for severe storms this year. What that means is that the southeastern states are under the gun again, and we might start to see a lot of activity ramp up over the summer in the high plains. In the central plains, there may not be as much. In the Midwest, you'll get the occasional event or two. But what I found most odd about last year's severe season is that the northeast, like the way northeast, had more tornadoes than the plains in 1 month. So,
Yep.
even though they were EF0, EF1, there were more tornadoes noted over Maine than there
Kansas.
were over Kansas or Oklahoma. I think that was in the month
Right.
of July, which is interesting to note. People in those areas are going to have to monitor for future forecasts if troughs can actually pick up at the right time. So with low pressures forming here, they'll shift southeast and then eventually push off towards the north and east. That would mean a cold front would be extending. Let me change a different color. That would mean a cold front would be extending south this away, dragging up temperatures, dragging up dew points like this. So you can see, particularly in this run that we're talking about, and particularly for this setup, the moisture is present over these areas of Dixie Alley, particularly in Florida, Mississippi, Alabama, and South Georgia. If you can get stuck in these, and if the low pressures can actually drape far enough south to which you can get stuck in a little bit of a warm sector, and warm sectors enhance thunderstorm development, warm sectors enhance the temperatures briefly in these particular areas, the enhanced conditions. If you get stuck in a warm sector, you're going to be primed for supercells ahead of the front in areas like around here. So this is just hypothetical, but if that were to occur, you'd be primed for supercells in these areas that are ahead of the front that have sufficient moisture and sufficient instability. That is the kind of pattern we're going to be looking towards for this spring and summer. And Josh, I'll let you get a word.
Yeah, I was going to say a couple things on that. As you was talking about the warm front, a lot of times, especially Dixie Alley, the supercells, they love to ride that warm front. And another thing, you don't have to have a lot of cape down here. Low cape, high shear storms happen all the time. Fultondale, prime example.
Fultondale was a very good example, and I believe it had 1,500 cape, but it had helicity values nearing 500. So that was really what enhanced the lift and spin of the storm.
Oh yeah.
As it ended up not forming, it already had formed. It was a linear wind threat. As it ended up rotating at the surface, which ended up producing a strong tornado.
And another thing,
High NEF3.
another thing that I mean, it's actually been a trend over the last couple of years. Is the classic tornado alley has, if you look at the totals, it has shifted south and eastward. Uh, I don't know.
And a bit north too, I would say.
Yeah, it's, to me, I don't know if it's something to do with the jet streams, the northern jet, El Nino, La Nina, or something like
Right.
that. Could be
Yeah, that's
something.
like the classic tornado alley there now.
That's
You
what
just
we're
gotta draw
accustomed
up.
to being the classic tornado alley. And over the last few years, we started to see totals shift to around here for in terms of the more tornadoes. So we've started to see more storms form in around these areas that have been capable of producing in tornadoes. Florida's just built differently. It just has its own thing. So we'll leave it out
Right.
of that. But in this case, the tornado numbers have been shifting, like Josh said, to areas like Dixie Alley, Arklatex, even into portions of the Mid-Atlantic and the coastline.
Yeah.
Our
was-
geomagnetic poles,
Yeah.
the geomagnetic poles are also shifting more rapidly right now than they had been in the past. I'm really interested to see how that could be playing an effect here, because I do know, like Josh said, the La Nina, El Nino, those do have huge effects on the trends with tornadoes. I've gotten graphs next to one another, and there's a lag behind the solar cycle for the ocean temperatures. That is La Nina, El Nino. And they also very well align with the tornado activity.
Mm-hmm.
Yeah,
Meaning
Yeah.
this would be a pretty moderate, high moderate year ahead of us.
Yes.
yeah, I agree 100%, and I would love to see, like you said, the poles shifting quick right now, quicker than they have. So I'm sure that has a lot to do with it, also.
Yeah, I was gonna say when you're going over the warm fronts and cold fronts associated with low pressures, sometimes they'll ride more north, and you have to watch the triple point and the occluded front for some higher vorticities.
Yeah, higher vorticities, as well as potentially even stationary boundaries that might occur along the fronts that might really set as a
Yep.
kind of hub or a station for storms to develop. And we'll monitor long-term trends and analogs as we go through the following weeks, as we really start to get into storm season. As meteorological storm season started at the beginning of this month, it is March the 5th. We are technically underway. And over the next 3 days, we have three general risks. Great times. So we're really gonna have to start noting the potential for severe weather in the southern and eastern United States, as well as potentially the Midwest in an isolated fashion, the Northeast in an isolated fashion, and potentially the plains early, which is what we've been seeing for low pressures. Some of them eject what seems to be up here and produce fronts extending out like this that would produce thunderstorms developing up here. That's really it for what I know, at least at this point, in terms of what we can really confidently cover at this point. Amy, Josh, Greg, Kyle, anything to note?
I was just going to say, I think that Kansas and Oklahoma will see a higher number this year, but not like, you know what I mean? Not like what years were in 2010, 2011.
Not like 2011, no.
Yeah, nothing like that. It's like you're saying, Tornado Alley has definitely shifted, Tornado Alley, it can happen pretty much anywhere in the United States, but the general area where you see tornadoes present has shifted or appears to have shifted towards the south and east, and even a bit into the northeast, which is very surprising.
Mm-hmm.
That's all I pretty much have to say, man.
I agree with that. And I also like to make note of the good news with this humongous cyclone Iran, that if anybody wants updates on that, my Weather Woman YouTube page has the forecast for it. And luckily this thing was like a Cat 5, like going right toward an island, and it's skirting just south of it, like my very first forecast. So just so happy.
Nice.
Things are going to be damaging, but not like completely demolished,
but not like
they
devastation that occurred with stuff like Ada that we had this year in the Yucatan, and then eventually as it shifted up towards the Gulf of Mexico.
Yeah, or even Laura.
Yeah, Laura, Sally, in terms of flooding, Sally was a
Yeah.
drencher, which was just horrible for those
My head
areas.
was talking about all that.
I think even Cristobal was a drencher, wasn't it?
Oh yeah.
Somewhat
Oh,
of one.
There was
Like,
there
the
was so
man
many of them this year.
was horrifying. Oh my gosh, it killed people in Guatemala. That's where I was tracking it from. And we'll
Wow.
touch on all the tropical activity. We're already way above regular or average sea surface temperatures in the Atlantic, and there is an X marks the spot already near Europe that could turn into a disturbance. And so
Oh
that's
wow.
another thing with the tornadoes you were talking about on the East Coast. A lot of those extra tornadoes that happen in Maine, even all the way down to Virginia, had to do with
Remnants.
whether or not the cyclone or hurricane there was close to land or not. There was still moisture, like hundreds of miles away, pushing into the fronts that were coming down, just like you showed.
Yeah.
So that kind of interaction, again,
Yeah.
tornadoes.
And what I saw over the summer in terms of tracking tropically, there were moisture jets that were visible via dew points, via relative humidity models that were dragging down all the way from the northeast and from the south right into the storm. So, in terms of that, the potential for another strong tropical season is upon us. We could start to see a repeat of last year in terms of tropical numbers, and a repeat of the tornadoes for these areas, and repeat of the tornado numbers. And speaking of tornado numbers and speaking on tropical activity, historically, Isaias this year produced historical tornado numbers. So
57.
yeah. And we haven't seen anything like that for tropical systems since, was it Andrew or something like that? I don't know. I think it was
Yeah, so that
Andrew.
was one of those instances where there was a low with a front over, let's say, like Ohio Valley area that collided, and 57 within, I think, like 4 or 5 days.
Mm-hmm.
I think there's a couple storms that did that. I think Isabel might have done that as well.
I think Ivan maybe.
Ivan, Isabel, and any storm that basically hits around North Carolina, around Wilmington, and moves up towards the northwest and then shifts back out towards the northeast usually drops a lot of tornadoes.
So this area that I just circled was what I recall for most of the tornadic development there, and I remember the night of tracking that, about 2:30 in the morning. We had a couple PDS tornado warnings for these areas along the border of North Carolina and Virginia, and then going on through the next day with the remnants of it moving up towards the north and east, towards Vermont and New Hampshire. We saw a lot of tornado warnings in Massachusetts, Connecticut, New Hampshire, not many of which ended up producing, but just goes to show the amount of storms that were able to spin up with the cold front colliding with that tropical storm. So we're going to have to monitor trends like that for this year.
Hell, even Delaware got tore up last year with tornadoes from that.
Mm-hmm.
That's what I was going to say. Delaware had 4 in
rarely
one
gets
day.
tornadoes, man.
Yeah.
We had 4 in one day, and our longest on record ever with that tropical system.
On a good note, not one of these storms worldwide, because I tracked all of them globally, not one had more than 200 deaths, which is astounding considering what we've seen in the past. Some of these storms would have taken out 10,000 people before satellite data and forecasts from people like you guys.
Mm-hmm. So we're going to continue to monitor trends and forecasts and analogs for this particular season. We'll give you updates as we get more information on that. But for now, covered the earthquakes and we covered the severe weather potential. That's basically going to wrap it up. We appreciate you all tuning in to this podcast. Yeah.
Hold up. Amy, promote your groups and stuff, please. You want to promote all your groups?
Oh, yeah,
promote your groups, your pages, your stuff like that.
Oh, sure. Yeah, I'm having trouble hearing him. But yes, so on Facebook, I have a Weather Woman is the page account. And then also on YouTube, I have Weather Woman Amy Metz, where I post global forecasts and other information. And I just started TikTok, Amy's Weather on Twitter and Instagram, Amy Metz Reporting, still from when I was reporting and producing news more than focusing on weather, which is my passion. So I'm happy to be back to this. And I'm so happy you guys had me join in on your podcast. I've really enjoyed what you guys are putting out, and I'm happy to be a part of it.
We
Not a problem. Thank you for your help.
Yeah, we appreciate the assistance on the earthquake situation, what we could have going on with that. So the amount of stuff you have to
Great.
bring to the table here is tremendous, and we really do appreciate that.
Oh, thanks. I'll always have tsunami warnings out there, just so everybody knows. I have a 10-year track record of having perfect tsunami forecasts. So when they hit, like I said. When they don't hit, I said they wouldn't hit. So I
Yeah.
hope I can keep that going.
Yeah.
Awesome. That's great to have.
Definitely.
Yeah.
Kyle, decals.
Yeah.
GoFundMe.
So what Greg was holding up is our United Weather Network decals, which we have for sale, $5. Basically bumper stickers that you could really attach to your car. They're weatherproof. And you also receive them if you happen to donate to our GoFundMe page, which is linked in the description of this stream and this video. It will be a video. So yeah, if you want to assist in research, tools, funding, etc., you can always drop whatever you have. Helps.
And you've got
this
nice
kind of
sweatshirts on your group and also your page, right?
Yes, if I recall correctly. So, the GoFundMe is pinned in the United Weather Network group, as well as the decals bumper stickers. So, really gonna start spreading after that as Greg moves his head to show it. So
No, sorry, I'm looking at my earthquake thing here, and I'm just watching New Zealand just